Assalamualaikum students. Today we are going to discuss about information security week 2 lecture, and in this lecture we will discuss how we can make a secure software product. So let's begin. In yesterday's lecture we have discussed about the five pillars of information security, that is confidentiality, integrity, and availability. So confidentiality is that when you want to access the data, it is being accessed by only legitimate users and not everybody else. While in case of integrity, integrity means that data will remain in its original form and there is no tampering or there is no change in the data. So data should be integrity should be maintained, and then there is availability of the data. That data should be available for all the users. So let's begin the topic of how we can make software products that are secure. Okay, so the one of the way to make the software product is one of the most traditional systematic way to produce a software is using software development lifecycle, and it is basically the methodology and implementation of information system. So it is a formal way of solving any kind of real world problem and make it into a form of a software product. So it is a structured sequence or procedures in which we can able to make a software development. So there are multiple phases. If you see, the first phase of software development lifecycle is analysis or requirement gathering. In this phase, we will gather the requirement and then we make a logical design like how things will work. If we are working on a web development, so what would be the required functionality of that website, how the data will be stored in the databases, how the user will interact, and what would be the size of your server, what would be the capacity of your server, how much user it can be able to facilitate. So that these are those questions which we perform during requirement phase, and we will ask the customer or the client that what is their demand, what they want, what is their requirement, and then we make the logical design that how many classes are required for this, which programming language is being used, how we make the connection with the database with your website, how many buttons, and what would be the layout of your website. So that is how we will make the decision in logical design phase. Then physical design and implementation is being carried out, and after the development of the website, the deployment phase is being undertaken, in which you will make your server live in your web application hosted on a server, and in which users can able to access your website uh, through the internet. So that is how these phases are the basic phases of developing any software development lifecycle. And then you will continue to maintain the changes that are being carried out. In secure system development lifecycle, we provide security in each and every step of the software development lifecycle. So in software development lifecycle, if we study the basic software development lifecycle, the first phase is investigation, in which you examine the event or plan initiating the process, specify objective, constraint, and a project scope, conduct preliminary cost benefit analysis. Okay, so in this investigation phase, basically you will plan out all the processes with the help of the stakeholders, your client, and then you will specify what are the objective and constraint or project scope. It is very important phase because in this you will define that how much work you will be going to do in this project. What will be your timeline? What would be the cost involved? How many resources are being required to fulfill this? So that is how you will do it. Then comes analysis in which you will study the functional and non-functional requirement of your project development, in which you perform feasibility of the project. Either it is viable product, are you making the either the client is making some realistic requirement, require some product which is realistic enough, uh, existing technology is supporting the requirements of the client, then you are going to perform analysis on each and every functionality of your product. Use information from the investigation phase, assess the organization, its current system, capability to support, and propose systems. Determine interaction of new system with existing one, and with documentation or finding updated feasibility analysis. So that's how you are going to work on it. Then comes the logical design, and it involves 30% of your project, in which you will create the basic structure of your project or your software. Create a system solution based on business needs. So um, it's the duty of the software developer to understand the requirement of non-technical user or non-technical client, and then mold it into the business need of the client. So if your product is useful for the customer, then he is going to use it. And if it's not useful, then he is not going to use it. So that is the first and prime objective of your software, is that it should be in accordance with the business requirement of the client. Act as a blueprint for desired solution without specific technology referred. So it is basically the the logical schema, or like you are making some database application. So first of all, what you are going to do, you will sketch and make DFDs or data flow diagrams, and then ERD diagrams, and then you are going to make then you are going to start working on developing the schema of the database. So that is, these are those steps you are going to take to make an application that use database management system. So first of all, you have to make the logical design of your software before starting working on anything. Like you are using the wireframes using Figma to understand the requirement of the users, and then further you will move towards the development stage. You have to generate alternative solution with respect to strength, weakness, cost, and benefit. So the strength and weakness is depend upon your team and your capability. If you have, for example, a client ordered you to make a mobile app that is based on Android, and your team don't have any developer who know how to develop such application, so it would be difficult for your team to make such application. So it's the duty of the project manager, or it's the duty of the scrum master to understand what are the strengths and weakness of its team, and calculate the cost that has been involved in development, and what would be the benefit for the company. So these are those things which we are going to understand in logical design phase while developing the software product. Then here comes the conclusion of the feasibility study of your software development. Then comes physical design. In physical design, specific technologies to support logical design are chosen. So in this, phase, physical design is being carried out, and in this you will understand what are the technology, what are the frameworks you are going to use for development of your software product, and then you will evaluate the component based on make or buy decision. So in this, for example, if you need some API key, you are required to use some OpenAI API to use GPT-4 in your application. So you have to buy a key to make things work. So these calculations should be done in physical stage so that you may communicate the requirement or the things that are required for the execution of the product. So that is how you will estimate each and everything that is required. Present the entire solution to the organization management for approval after the feasibility analysis. See, लेबल देखो, मुझसे तो वो एक्सरसाइज वो भी नहीं देखी फिल इन द ब्लैंक. Okay, so now we will continue. Like in physical design, specific technology to support the logical design are chosen and evaluate the component based on make or buy decision. Present the entire solution to the organization management for the approval after um, after okay, students, let's continue. So design phase in logical physical design phase, you will make the prototypes and you will share those prototypes with the client to take the approval from the organizational management. If they need some kind of changes, they will inform you and they will told you that how you are going to change it and what are the things that make them comfortable. So in this phase, you are going to make frequent meetings with your client and discuss what are the possible ways to make the solution that are fulfill their requirements. Okay, then comes implementation and testing phase. In this, you are going to make software, create a software, make start coding on it, start using the technology, then perform unit testing or component testing, then also train the users to how to use your system. So after individual testing, system-wide tests are being conducted. So conclude with feasibility study and performance review. So you will make analysis on each and every step to understand that it's fulfilling the requirement of the customers. Maintain and change. Longest and most expensive phase, support, modify the system throughout its life, include periodic testing, feasibility, evaluation, management of updates, continual monitoring, ensure system effectiveness in relation to organizational needs. If it's no longer supportive, a new project is being initiated. So that's how you are going to deploy your project on user premises. If it's in-house development or they want not to make it live, not to make it available online, then you have to develop in user premises, or you will make your server live so that everyone can access your website. You will host your website. So that is how you can deploy the product. So it is the most expensive and the longest phase. It should be flexible enough that it may able you can able to modify or change the system throughout the life. Periodic testing is very important, so you need to manage your product for long term for the client, and continuous monitoring to ensure that system effectiveness in relation to organizational needs. If it's no longer supportive, new project is being initiated. So that is how we are going to develop the normal software instead of making it a secure software development lifecycle. Now we will study how to make these phases a secure one. So security should be at each and every step. It should be baked within your software development life cycle. Okay. So we, how we can make the system secure? We have to adapt security system development life cycle. So adaptation of traditional SDLC to support information security and project. Focus on identifying specific threats and creating control against them. Make security a coherent program rather than a random action. So, the software development should be big and it should be mitigate all the attacks and malicious code. You have to inspect either there is some malicious code that has been present within your code, so you have to identify those snippets and make them more robust. So you know that there are two kind of programming language. One is machine language, which is also known as low-level language, and there is a high-level language in which there are five generation of language. So first generation is all machine language, second generation is family language, third generation is all compiled language, fourth generation is natural language like SQL, and fifth is all programmer need to create their own visual interface, like they have to drag and drop and automatically code is being generated like visual basis. So that is how uh, we we have developed the programming languages. So in secure system development lifecycle, initiated by upper management, defining process, outcome, goal, budget, and constraint. If we want to make our system secure enough, so that should be within the policy of your organization. This thing has to be decided at the organization level, at the upper management. Like they want to make their system secure enough because security costs a budget overhead. You have to make another layer over your software development. So it may increase the development phase as well because you have to ensure that there is no malicious code that is present within your software. So you have to evaluate each and everything. Typically start with enterprise information security policy. So you have to define certain policies that will help the team to ensure that security should be enforced within the development phase. Involve organizing team, analyzing the problem, defining project scope, goal, and objective. Everything remains same. but you have to decide that security should be enforced within the developmental phase. Then comes analysis, review documents from investigation phase, perform analysis of existing security policy, threat detection and control, address relevant legal consideration, specifically privacy law. So we will understand that all the privacy laws are being fulfilling and there is no loophole in ethical guidelines or the policy. So, and we have to also be sure that there is no security flaw in design phase. Initiate risk management, assessing threat to organization security and information. Then we perform logical design. Continuity plan is being made. How will business continue in event of loss? Incident response. How if an incident has been occur, if a threat has been occur, so how your system or your software should be behaved, how you are managing the disaster management. If in case of a disaster, how you're going to recover the information. So these are those important questions that you are going to ask during the logical design. Then physical design, develop alternative solution based on logical design, define success criteria, design physical security measure, end with feasibility study, and a presentation to stakeholders for design and approval. So that is how you're going to work on the design phase. Then comes the implementation, acquire, test, and implement security solution, address personal issues, conduct training programs, entire tested packages present to upper management for approval. Maintenance and change. Constant monitoring, testing, modification, updating, and repairing due to ever-changing threats. Traditional SDLC framework doesn't typically anticipate software attacks, require application, construction, and continuous adjustments are being made to counter the emerging or evolving threats. So you have to maintain in each and everything. So basically, you have to perform analysis that either the development you have done is containing some backdoor or containing some malicious code. If there is present, so you are going to mitigate those threats or information. So that is how you can make the secure software development in the requirement phase, design and implementation phase, then test, deploy, and maintenance phase. So the requirement and design phase is basically in which you are integrating the security goals, like you have to enforce the policy that are in accordance with the business requirement. Then threat modeling, you have to understand what are the basic threat signature, how can a threat can be acted on a software, so how you are going to secure your system, so you are going to understand what are the possible risks that can make your system vulnerable to the threat landscape. So you have to mitigate those risks and start implementing the code. So during the code implementation you have to perform static analysis on your code, like if it is the secure form, the repository you are taking from the GitHub are secure, or they are containing some loopholes, or there are some vulnerabilities that can be exploited by the bad actors. So you have to mitigate those code and you have to ensure what are the risks involved in using those codes. Then in testing phase, you have to perform penetration testing to check what are your weakest points, in which areas you are weak. So it is basically the vulnerability assessment you are going to perform on this phase. And then you start monitoring the entire life cycle. So that's how you are going to work with software development life cycle in security form. So static application security testing. In this, basically, we analyze the source code, bytecode, or binary code. In dynamic application security testing, we evaluate application during its running state. And this is being happen after the development. During the deployment phase, we are going to analyze it throughout its life cycle. And static one is being under process during your development, like you are started coding, so you will evaluate each and every line. So when you use early stage of development before code is run, ठीक है, ये कोड जब तक के यूजर प्रेमिसेस में रन नहीं हुआ होता, जब आप डेवलप कर रहे होते हैं, then you are going to use static application security testing. After the application is set up and running, often in stage or quality assurance environment, you are going to perform dynamic application security testing. Okay, so code evaluation is being done during static application security test. Access to source code or bytecode. No operate from outside in without access to underlying code. Identify vulnerabilities in the code base. Identify vulnerability that can be exploited during real world attack. So that's how you are going to work with these two type of testing. So what are the advantage of static is that you can able to detect the vulnerability at the most earliest stage, extract location of issue, doesn't need fully deployment of your application. Okay. In case of dynamic, you will understand the vulnerabilities, the new attacks, like there might be some attacks that are 0-day attacks. So you can able to detect those attacks as well. So it will provide you real world attack perspective, doesn't need source code. What are the disadvantages? There might be some false positives, cannot detect runtime vulnerabilities. None of pinpoint exact code location of vulnerabilities conduct later in development, so fix can be more expensive. So, what are the most common vulnerabilities that are being detected are SQL injection, cross-site scripting, buffer overflow. Then other vulnerabilities at the deployment stage can be authentication issues, session management issue, insecure direct server misconfiguration. So these are those common vulnerabilities. Interaction with apps, non-interactive, uh, so analyze code without running the application. Interactive जो है testing the running application mimicking the real world attack. So that is how you will going to evaluate or test the security of your system. So you can see the major difference between the two phases. In first, traditional requirement is being gathered. In case of secure software development lifecycle, security requirements are being collected. Then in a traditional, a design is being made. In case of secure software development lifecycle, architecture is being designed and reviewed, and risk assessment is being also performed. Then in third stage, development is being undergo, and you will start developing your software. In case of secure software development lifecycle, you have to model the threats. You have to understand what are the possible vulnerabilities, what are the risks involved, and you have to mitigate those risks as well. Then in fourth stage, testing has been performed. In fourth stage, implementation and code are being reviewed. Like you have already written the code, but you have to perform the review that which part of code is being vulnerable for security threat. Then in fifth stage, you are going to deploy the software product. And in software development lifecycle, you are going to deploy the software and you will start doing the testing. Like you will perform dynamic testing and static testing as well. You have already performed static testing. After deployment, you are going to perform the dynamic testing of your secure software development. So this is one of the video you will watch later on. I will provide you the lecture. So you see, let's play it and see how he's going to. This is one of the software which is known as white spot, and it is being used by making your software secure enough. It will understand what are the risks involved. It will tell you its dashboard will tell you what are the risks involved, what is the level of the risk, and what type of vulnerabilities that are being present. So you can go and see its demo so you can understand how you can able to get benefit from this, but this one is paid one.
Let's scan some repositories using Application Security Portal. In this demo, we will import repositories from GitLab using a personal access token. On this step, you need to select the repositories you want to add to any of your products. You can create a new product right from this screen if there isn't one that works for you. Each repository will be added as an asset to define product. Let's add a new product and name it vulnerable_product. Its product type will be public for our demo. You can use product types to refer to teams or just leave it blank. There's also a tab with Jira settings, but we'll keep the defaults. It's handy to quickly put a product team space to pass issues right there. After creating a product, we can also create a new one for each repository, or simply link multiple repositories to our new product. After you finish mapping new assets to the repository, the portal will suggest you to run an audit. Let's run the audit right away. There's a default scanning sequence with code scanners. Our portal will clone all repositories, execute scans, and pass results to define products. Let's see what's going on behind the scene. We have an interface for engineers to see all pipelines with all jobs and logs. As we have 4 repositories, there will be 4 pipelines. As I've mentioned, there is a dedicated step to clone repositories, 2 secret scanners, and a code analysis tool named SemGrep. You can add your own scanner images, add and change any sequence and job commands. And once again, this is a self-hosted solution. At this time, as we can see, the first vulnerabilities have already arrived in the portal. Within literally 5 seconds, some of the vulnerabilities will be marked as false positives. Here they are.
So
now you can work
that
with
is how
identified vulnerabilities and create more validation.
that is how you are going to understand what are the vulnerabilities involved and you will overcome those vulnerabilities.
Let's scan some
Now, this is another software that is check marked, and it is also being used by many companies to understand what are the possible vulnerabilities and how to mitigate them. So it will tell you what are the malicious code and what are the risks involved in it. So how you are going to overcome that. So it supports JavaScript, Apex, Java, PHP, Python, Swift, Scala, Perl, Groovy, Ruby, C Sharp, .NET, C++, Oracle. So number of so programming language is being supported by this software. Then Bandit, this is the free package or a library of Python. You can use it to understand what are the vulnerabilities that are present in your Python code. Then there is Contrast. This is another tool which supports Java, JavaScript, .NET, .NET Core, Node.js, Ruby, Python, Golang, Scala, PHP, Kotlin. So this will help you to understand what are the malicious code or possible risks that are being present in your code, and your team will going to mitigate that. Then Fortify Static Code Analyzer. This tool will also support to understand the vulnerabilities that are present, like .NET. It will support these languages to understand the possible risks and threats that are being present in your code. So, vulnerability assessment, there are further assist, assessment tools that are being present in your Kali Linux, which are free and open source library like Nikto. It's an application that scan web-based applications and web server for known bad files that could potentially be dangerous. Other things that it can detect include outdated config. It will detect the the port scanning, configure, configuration file, username, enumeration, and more. Skipfish is automated tool that perform reconnaissance tasks on web server. It generates a sitemap and then recursively probes the site with penetration tests to identify vulnerabilities. Then WebKey is another penetration tool that manage the probe commons such as SQL injection, cross-site scripting, and it uses get and post methods as a part of attacking capability. Then WASP is Z attack proxy scanner is pen testing app that allow you to test web application still in development stage. This lets you design tests to find problem before they get released into production environment. Then Spy is the name suggests is Python tool for testing for cross-site scripting vulnerability in website, web application, and after an initial scan, the map out the entire site. It then begins the detailed task of scanning every element that it uncover in search. W3AF is a web application framework that lets you attack and audit web app and uncover exploit web application vulnerability as a part of your vulnerability assessment. It is available as a GUI console application and it has over 130 different plugins for different tasks. Now, there are further for network infrastructure. If you want to understand what are how which resource is possible vulnerable and attacking your server, so these are those tools like OpenVAS is one of the tools that will let you know that which computer is being infected, which end node is being infected. So this will help you in that. Metasploit is another tool that will help you to pen test and it will scan your entire network and find the exploit if there is any present. Nmap is there, Netcat is there, Unicorn scanner is there, Strengths is there. So that is how you are using these tools to understand the possible vulnerable or risky systems or resources, and then you will going to mitigate that and overcome those challenges. So that's all for today. Just read it this topic. If you find any confusion, if you want me to let you know about any specific module, then we will discuss later in class. Thank you.